Let's go to page 166 and start with number 197. So you want to prove that if a quadrilateral is also diagonal, that means the diagonals are perpendicular, then the area equal to half the product of its diagonal. Okay, so let's draw a quadrilateral. First, let's go and get our diagonal perpendicular first. Okay, then from here we can go and draw our quadrilateral. Okay, so this is perpendicular, so it's A, B, C, D. Okay, so the area of the ABCD, so what we're going to do is we're going to break into the two triangles. And I'm going to call this point E. So we're going to divide into two triangles, so divide into these two triangles. So for this triangle right over here, it's going to be 1/2 base times the height, which would be AE. Okay. Plus the lower triangle would be 1/2 the base times the height, which is equal to EC. And then go and factor out the 1/2 BD. So you're going to get AE plus EC. Well, AE plus EC is just AC, right? So the area of this quadrant would be 1/2 BD times AC. So which are the diagonals, right? So BD times AC half will give you that. Okay, so that takes us 197. Let's go to 198. Okay, a rhombus is inside a circle. Okay, so you have a circle, and inside is a rhombus. Okay, the only way a rhombus that can inscribe in a circle is a square. Okay, so you have a B, C, D. Okay, so a rhombus, you have to be a square, and it says that the length of one diagonal is AX. So if this is AX, what would be the length of the other diagonal? Well, the length of the other diagonal have to be AX also, because it's a square, so diagonal have to be the same. So this one, the answer is AX. Okay. So just have to realize that the only way you can inscribe a rhombus in a circle is a square, because a rhombus, if it's not a square, if it's like this, then you cannot get a circle around it. See that? Okay? These two sides not going to touch. So again, the only way that the rhombus is going to fit in a circle is when it's a square. And if it's a square, the diagonals are equal. So if one diagonal is AX, the other one would be also AX. Okay, let's go to 199. So they give you this figure over here. Okay. Okay, so D, U, C, K, and this is 15, this is 13, this is 5, and this is 20. And looking for the area. Okay, so what else do they give you? Okay, so that's it. Okay, so what you want to do is you want to, whenever you're looking for areas, just cut it into pieces. So if this is 15, this would be a 15. Okay, now this is a 5, 13, so this would be a 12, like 5, 12, 13. If this is a 12, this would be a 12. And now you have to look for this side over here. So if you kind of call it, you can call it x. So you're going to have the x, 12, and 20. This one you can factor out the 4. So this would be a 3, 5. So from here you can see that this has to be a 4. And so x will equal to 16. Okay. And so now once you have all these pieces, now you can go and get your area. So k, the area. So this one is 1/2 base times the height. The middle, the rectangle would be base times height. And this triangle will be 1/2 base times the height. And just go and figure it out. So this will equal to 30 plus 180 plus 96. So area equal to 306. Okay, let's go to 200. Okay, from the area of the rhombus with a side of 13. So you have a rhombus and a side of 13. And one diagonal of 24. So this diagonal is 24. Okay, so what you want to do is go and draw the other diagonal. Now since the diagonal is 24, so this would be a 12 and be a 12. And from your Pythagorean theorem, the spatial triple, you know this has to be a 5 and a 5, right? Okay, so the area, you can just diagonal times half, or you can just figure out the triangle. Okay, so the area equal to, if you just look at one triangle, it would be 1/2 the base times the height, and there are 4 triangles, so you times it by 4. So again, there are many ways you can do this. So you can just diagonal times half. Okay, you can do it this way, and again, you can just cancel things out. Okay, so k equal to 120. Okay, let's go to 201. Okay, so the diagonal of the rectangle lot is 37, so it's a rectangle. And so length, width, length, width. And the diagonal is 37. And it says the length is 1 less than 3 times the width. Okay, and so you're looking for the fence required to enclose the lot. Okay, so this is a rectangle, so you can apply the Pythagorean theorem. Okay, so you got 3w minus 1 squared plus w squared will equal to 37 squared. So go and work it out. So 9w squared minus 6w plus 1 plus w squared equal to 1369. Okay, move 8 into one side. So you have 10w squared minus 6w minus 1368 equal to 0. Divide by 2 to lower the number. So you got 5w squared minus 3w minus 684 equal to 0. So now when you use master product, you're going to get -3. And this would give you -3420. Okay. Okay, so now if you use master product, it's going to be kind of long. So other option would be use quadratic formula, or you can use complete a square. Or another way to do this is that this number, you can kind of figure what this number is. can have. Okay, so if you notice, if you break down the number, or you can use this one. So you get 3420. So if you get, again, break down to prime factorization, so 1710 divided by 2, you get, okay, and then divide by 3, okay, divide by 3, okay, and then divide by 5, you get 1, 9. Okay, so this is all the factor, right? And so you want to find the combination of this product that's closest to the 3. Okay, so if you notice that this and this will give you 57, and this over here, so this will give you 60. Okay, the other will give you 60. So you're going to get 57 and 60. Okay, it will give you difference of 3. So what you need to have is 57 comma negative 60. Okay. So sometimes if the number is big, you want to use a prime factorization and break from here, you can see the combinations. Okay. Again, the two numbers are fairly close. And so again, the 3420 is approximately kind of close to 3,600. So the square root of that would be 60 and 60. So the two numbers, since this number is kind of small, that means two numbers are fairly close. And that means that's going to be around, close somewhere about 60, okay? By taking the approximation of the square root. So you're going to be, somewhere it's going to be around 60. So you come to here to see what combination of the factor will give you close to 60. So 3 times 19 will give you 57. So that's pretty close to 60, okay? Or if you try the other one, give you 60. And from there you can figure out this very quick, okay? Or another option is just use quadratic formula. So those are set different options. So you got W, 5W, so this would be the inside, so it would be minus 12, and this would be the outside, so it would be plus 57. This one is going to give you negative, so it's not going to work. So you're going to get W equal to 12, so L equal to 3W minus 1, so it would be 3 times 12 minus 1, so L equal to 35, okay? So the rectangle you have, so this would be 35, and this would be 12, 12. Okay? So the perimeter you need, or the fence you need, so perimeter would be equal to 12 plus 35 plus 12 plus 35. So perimeter would give you 94.